So today we'll discuss those doubts on magnetism. Okay, you have posted your doubt in group already.
Okay, sir.
No. Yeah, this was it, no? This was a
Yes,
doubt.
sir.
Conductor of length L is placed perpendicularly to a horizontal uniform magnetic field B. Suddenly a certain amount of charge is passed through it when it is found to jump to a height h. Okay, so this is the conductor here, conducting wire, and it is placed perpendicularly to a horizontal magnetic field. So say this is the magnetic field, it has to jump. Okay, so here, see, obviously must be some connection is there, some battery is there which will make the charge pulse flow. So some battery is obviously there. However, this is the rod having length L, and this is the magnetic field B. Suddenly a large amount of charge is passed through it. Suppose the large amount of charge be Q.
Sir, which direction is this? Which view?
See, it is the horizontal direction, right? So there it is, this G is downward. So, I mean, this screen is in the vertical plane. The screen is in the vertical plane. And see, there is loose contact here. And these contact are loose contact, so that the wire can jump up. Once a sudden charge passes through it, the wire can jump up. Now, why it will jump up? See, if a current I flows through a wire, say.
Sir, I would like to see the question once again. 1 minute, sir.
Okay.
Okay, sir.
Okay. So if a certain amount of current flows to the wire I, and there is a magnetic field B, and this has length L, what is the force then upward? So here, so IL cross B, see, it's 90-degree angle between I and this length and B. So there the force will be equal to ILB, right? Now here what happens? So as the charge passes suddenly, right? So there is an impulsive force. So here actually force, we can write force equal to ILB. Now this we can write as, okay, let's do it like this. Force is equal to ILB. So the impulse of the force in time delta t. What is delta t time? The time taken for the charge to flow. Time in which charge Q flows. It flows in a small time t. So that is why I can write the impulse of the force. Force is integral f dt from 0 to delta t. So here, so L and B are constants. So integral I dt from 0 to delta t, what will you get here? That's Q, right? This term is Q. So LB multiplied by Q. This is impulse, as you denote impulse by J. Now the impulse is changing momentum of the wire, current carrying conductor. So initially it was at rest, and suppose it gains velocity V upward. So impulse is the present momentum, right? So it is M multiplied by V. So V is the velocity gained by the conductor. And here M is the mass of the conductor, right? M is the mass of the conductor. So as I said that there should be loose contacts here, else it can't jump. Contacts are loose so that it jumps again. So it jumps up with a speed v, right? So that this mv equal to lbq. So therefore v is equal to lbq divided by m. Therefore you have been asked to find out the height, right? Height. So you know, if you throw a certain object, how much height it will rise?
Half
Before
mv square is equal to mvh. We can apply conservation of energy principle. Na?
yes, v square by 2g. So the height lambda out is v square by 2g. Just you can substitute. So there are 2g multiplied by, is it m square, right? Yeah, m square. So that is the height. This is the required height.